Hey guys, what's up? Eddie Aho here with KissAnalog.com. Alright guys, so it's been a long day, but I got a really cool video. It's a microcap tutorial, kind of. So I got a schematic from one of our viewers who wants to stay anonymous. The guy's pretty awesome, did a really nice job, and he's got a couple amplifiers. I'm going to make sure I have permission to show the other one, but he did a Wolverine. So if you guys, we did one for Q-Spice, right? We did a few for Q-Spice. So now we're doing one for Microcap. And like I say, it looks pretty good. It looks really good. So thank you, Mr. Anonymous. Appreciate it. You really did nice work. So, but anyway, some people are like that. As a matter of fact, you know what? That reminded me of an oscilloscope that a viewer sent me, and I packed it away in a box over here. It's been out of sight, out of mind kind of thing. It's a Rigo oscilloscope. I think what I'm going to do is do a giveaway when I hit 50,000 subscribers, okay? I'm going to give that Rigo away, and I'm going to give this power supply away too. I'm going to review this power supply, and we're going to pick some other things. I'm going to have a kind of a big giveaway at 50,000 subscribers. As a matter of fact, the next video, when I talk about this guy, I'm going to review this video, review this power supply here, and when I do that, I'm going to announce some winners of the channel. It's taking me a while because you know, I was sick and different things going on, and also just trying to contact these guys because some people went out and bought things they didn't want me to give them things. And so I kind of had to sift through and find some winners, okay? So if you sent me some things that you think you know, were sending them in to win something, send me your name, send me an email again, okay? And I'll see if you're one of the winners, because maybe I lost track, but I've been trying to find people to give things to. So anyway, let me know. Sorry about that, but some things happened, and on top of that, then I got sick, and God, time's gone by. But yeah, there's some giveaways, some multimeters I'm going to give away and stuff like that. So we're going to do a big giveaway when I hit 50,000. I'm approaching 30, probably be after the new year. Yeah, maybe you guys, yeah, maybe we can bump it up. Maybe I'll have to do this giveaway sooner because 50,000 might be too far away. But 50,000 would be awesome, right? Okay, let me show you this schematic. Let's get into this video, and yeah, let me know what you guys think, okay? Let's do it. Hey guys, so I have this schematic sent in by one of our members of the channel. Awesome guy, but he wanted to stay anonymous, so just showing you the schematic he sent me. This is for the Wolverine Amplifier, okay? So anybody who wants it, send me an email. Be a subscriber, please, and I will send you a copy. So here, let's go up to, see, we have the plus minus up here, right? And we go to the one right next to it. See, if I hold over it, it says auto scale. So I could have just hit the F6 button, but I'll hit this, and then it auto scales. We see the whole amplifier. All right, so on the left, we have the input circuitry right here. Okay, this is the input signal. And then what we have at this input section, the signal comes in this transistor right here. Okay, and then look, if I hover over it, he's got some information about the parts that he's using. He's done an excellent job here. So this is basically an op amp. If you think this is an op amp, this is one input, this is the other input, and then we have the output up here, okay? So that's one way to look at it. So this is kind of the mid-drive section, and this is this driver section is driving this output, these output transistors, okay? So then our output is way over here to the far right. We have our typical, LC filter, okay? Right here in the middle, see this circuit up here? And there's another one down here. This is the voltage regulator. So over on the far right, up here, we have a voltage source coming in, our plus minus voltage rails, okay, comes in, and then we have kind of an R here, so we have a RC filter, and then it goes to this voltage regulation. So this is where we get linear voltage regulation. So this is our linear part of our power supply on this side. Over here is still, the low frequency switcher filling up both capacitors right here, right? There actually is an R right here, a little small R to get a little RC filtering, but it's not regulated, right? So this is coming off the diodes commutating. So this is a low frequency switching power supply, just capacitor, both capacitors. And then we go through regulation for this circuit. So our input circuit is regulated, okay? It's got linear voltage regulation. So here, if I come up here to hit the plus sign, we can zoom in, okay? Now I'll just scroll over like this and show you this input circuit, okay? So if you notice the two voltage rails, 27K a pot, 27K. So this is kind of setting a DC average level right here in the middle, okay? So this voltage between the 27K and a 5K, we're trying to get the zero voltage rail right through here to give a zero voltage right here at the input, okay? So this is what we want to call our zero voltage, ground or return. The actual ground symbols down here. But yeah, that's what this circuit's all about, is trying to give us a zero voltage reference right here. Now we have a capacitive input, so we have a RC coming in, and that's going to give us the signal here. And then we have our feedback. See down here along the bottom, we have this compensation network down here. It's a filtering network, and it comes up into this transistor. So these are our two op-amp inputs, if you think of it that way. Okay, and then how much current they draw through here, that's what we amplify on these two transistors here that drive this output section. And then this circuit right here in the middle, this is setting up our bias network for our Class AB circuit, right? So this is our Class AB setting, or if we're going to be Class A, you'd set that up for Class A, but this is that network there. So these are the two drive transistors tied to these drive transistors, which, eventually drive all these parallel transistors out here on the output. Whoops. So coming out to the output, here's our output network, okay? There's our return right there. So, all right, so I just wanted to let you see what the whole circuit looks like. Let's zoom out again. Now, I'm going to show you two analyses that have been set up. So if you haven't done anything, in Microcap before, you can just pull up this schematic and play with it. So a lot of times I come down here, probe transient. So I can say probe transient, right? And then it's going to wait for me. It's doing some analysis now. And then I can come out here to the output circuit. See down here at the bottom, my bar's coming across here because there's a lot of parts on this board, and he's got a lot of, each one of these parts has a lot of parameters. Okay, it's coming to the end right here. Okay, once it does, see my voltage, it shows a voltage on my connector, so I can just go, okay, let's go right here to the output. I click on that. Okay, now I have to wait a minute longer. Now I'm running this on a MacBook Pro. It's an older MacBook Pro, so it's 3 or 4 years old, and I really need to get a new one, but gotta save up for that. But anyway, I'm going to zoom in on some of these waves right here. Whoops. Here, let's go up here, hit this guy right here so I can zoom in, okay? So then I come down here and say zoom in on those. So that's our output. Here's our zero. We're going up, to, if I hover over this, it says 26.58 volts. So I can measure that and stuff. I can go up to, one way to do it is go to this function, this fx, that's a go to function. So let's click on that. And then over here it says average, okay, V out. Let's go to RMS. So pull this down, and where is RMS? right here. Okay, so I go RMS V out, and it gives it a start and stop thing. I can just say click on the right, and it says 18.9 volts, or pretty much 19 volts. That sounds, I mean, without doing math, just, using it, intuitive thinking, it's like, okay, yeah, that sounds about right. Okay, so that's what you can do to measure your signals and stuff. And I'm just kind of going through this quick, just kind of give you a, quick look. There's different things you can do. There's these little peaks things. You can put cursors up at the peak right here. See how it goes to the peak? And so there's a bunch of different things you can do. But what I want to show you is, let's get out of this guy. And instead of doing the analysis transient like I did, the probe, where I just randomly probe whatever I want to, he's actually gone to the trouble to set up a transient analysis. Meaning, see right here, output divided by input. So he's got VR load. And here's the ranges right here. And so you can see all these signals, P out, RMS, current, R load. Okay, so the current going through the load resistor. This one's RMS of the voltage at the load times the current at the load. So you take the voltage times the current to the RMS. So and that's power out. So then he's got power load. So he just says PD R load. So these two things should be the same. Then he's done this way. RMS of VR load times, or divide by this one here. I'm not sure what that V3 is, but so he's got different things set up here, okay? So let's go ahead and run this. And there it goes. It's running. So yes, I'm running Microcap on Windows. So like I said, I have MacBook Pro. So it is running on a program called Parallels that lets me run all the Microsoft type Windows programs. So on Parallels, Windows is installed on top of that. And then I've got Microcap. And right now, it seems like it's kind of stuck. All right, guys. Hey, by the way, this is my amplifier that I built and did some videos on before. But let's pull up the other one. Okay, so here's the amplifier. We're back here again. Let's try it again. I don't know what happened. I haven't had that problem before. So I'm going to try to do it again. Transient. Here's all the setup. Let's do the run. Hopefully this time I'm not going to touch anything. I touched something on the keyboard, I think, and I don't know if I hit a pause button by accident. And, I don't know the keyboard shortcut, so I think I hit something and it stopped, and I wasn't sure how to restart it. So here we go again. You can see how it's just blasting through this thing. So, okay. So here is, let's see, what does this say? R load. So voltage at R load right here. Okay, here's the 0 volts. It's going up there. So we could, do the measurement on that. There's a red waveform in here. You kind of see it up here at the top. That is the RMS of the VR load. Oh, so there's the RMS voltage. So we can just go up there, and that's around 18.56. So yeah, so they already set that up. He also set up IR load right down here, the green one, and then the RMS. So we could take that value, 2.4, multiply by that and get the power. But he's also got a tab down here for power. So let's go look at this. And it says power R load. That's this kind of magenta or whatever you call this color waveform. And then there's a green waveform down here where you multiply the two things together, and that's this one. So let's zoom in on that. I'll come up here to my zoom button. That's this one right here, scale mode, F7. So see if I remember these function things, I could do it that way. So This guy right here, if I hover over the green one, it says about 44 watts. See the pink, magenta or whatever. All right, so, and then down here, he's got RMS, V, and time. So he just did a different way, I guess. I'm not sure. I don't know what this RMS of VV3. I got to go see what V3 is on the schematic, right? So we can go back to the schematic and we can look for V3. Oh, that's probably the input. Maybe I wonder if that's the gain. Let's go over here to the input. So I have to turn on the node numbers, right? That's this one. And I could turn off some of these other ones so I could give less things to try to read. Okay, that's node numbers. Let's turn off that one. Yeah, so where's V3? I know there's a search I can look for, but guys, I would have thought it would have been real easy to find. All right, well, that's interesting. That's not as easy to find. I turned off everything. I could leave these things on this information, but where the heck is V3? Let's go find it. Okay, so I think we look for these binoculars. Find Control F. What's this little binocular? Find component. So let's find V3. So we're looking for a node, right? And it's 3, so it's that one right there. And okay, so it's giving us all these 3s, like 37, 31, all that. Where is just plain old 3? Well, that's okay. 30. God, there's all kinds of node number 3s here, but I don't see. Okay, let's go V3. Okay, here's V. Oh, it's this guy here. Oh my heck, there it is. So yeah, all right, man. Sorry guys. You know, I play with all these different simulators, and so sometimes it takes me a minute to get back up to speed on what I'm doing with any particular simulation tool, but you know, they're all kind of intuitive, and so you can kind of see me fumbling through and you can eventually find it. But yeah, it was voltage 3. So VN voltage 3. So here's VN right here, and it's the VN's coming from V3. So I was looking for VN. I was thinking node V3. That's what I was thinking, but it's the voltage source V3. So anyway, he's looking at the output voltage over that. So that was the gain. So let's go back and look at that. So voltage of load divided by the voltage of the input. So this is the gain, 26.9. All right. Whew. All right, guys. So I guess that's probably enough for today. Oh, you know what? There's one more thing I want to show you. Let's X this one. Get rid of that guy. Let's go back to analysis. And this time let's do an AC. Because look, he went to the trouble to set up the dB and the phase of the VR load and VR load. So let's look at that. So we got dB and phase, okay? And over here you can see graph 1 and graph 2. So there's 2 graphs we should expect to see. And okay, there's dB, and here's phase down here. So look at that. That's pretty cool, huh? Here's 10 hertz. There's 20 kilohertz. So the darn thing's pretty flat. It's about, you know, what is this? If I hover over that 155 degrees and out here 20K, it's just starting to break away at minus 184. And whoops, come back here and go to dB, and you can see the gain. The gain log here, if I hover, is 28.5. So about 20 minus 3 dB would be about 25, right? So we come down here around 25. Now I could set up, so I'm just coming down. So yeah, it looks like it's well past 10 hertz where the 3 dB cutoff. Now I can come up. So right here, I got my cursors, right? And then I could grab these guys, grab that little box. And so I come up here and say, okay, it's 28.58. That at 190, okay, right here, 142 hertz is 28.5. So let's go to 25.5 is the 3 dB. So 25.5 is going to be right about there. Okay, so there's that one. And then I can come over here and grab this guy and pull it around and measure things too. So, whoops, did I get, oh, you know what? Sorry. Left mouse button and then right mouse button for this guy. There we go. So on my MacBook, it's a little bit different. I hold one finger down for left and two fingers down for the right. So if you're using a Mac, that's how you do it. All right, so yeah, I mean, it's nice that he went to the trouble to set up all this stuff to make the simulation. So you can play around and you can see the tabs down here. See where AC analysis, I can go back to schematic here, go back to the AC analysis. So, all right, there you go, guys. And by the way, if you want to come up here and see the limits, you can come up and set up the limits, look at all the limits, and this is a frequency band. You see 300K, over here is 2 hertz. So you can see he's got about 350K to about 2.7 hertz on the X. On the Y, you got that range. So yeah, that's how you can modify these things, see what it looks like, and just don't save it. Now, what I recommend doing is taking the schematic, saving it, and then saving it again with a slightly different name or totally different name, whatever, just a different name. That way you can play around with it, and if you really mess it up, you can always go back to the original and resave it under a new name and play around again. So yeah, you can't break it if you do it that way. You always have the original, right? So there you go. I'm holding two fingers down on my mouse pad when I'm moving around like this. On a different mouse pad, you do it different ways, but yeah. And I can do my fingers, pinch in, pinch out to zoom in, out, or I can come up here and do it this way and hit this guy to fill up the screen. So, all right, guys, hope you have fun playing with this, okay? Let me know what you think, and let's thank our viewer. Even though he's anonymous, let's all give him a thumbs up. All right, guys, hey, let me know if there's certain things you want to learn on, whether it's QSpice or Microcap. There's a few things I know that people have asked me to do, which I am going to cover. But let me, give me your ideas and things like that, okay? Give, comments down below, that kind of thing. And I want to do these Spice tutorials. I really like to do one every couple weeks, or at least one every few weeks or something like that. I've got audio videos. I got so many things to do. So many things to do. So, but I do want to I want book tutorials, things like that. Let me know what videos you guys like. And I can go by, the views, right? But I know that doesn't cover things because, for instance, my design videos, they don't get a lot of views, but I know people want to see them. So I'm going to continue doing them because that's really, my expertise. So I want to do those things, and I want this to be a channel where you can learn and grow and all that kind of stuff. So we're going to try to mix it up, and by hearing your comments, I'll have a better idea what kind of things to show and what kind of things to mix up. But yeah, I've got a few things like some generators, and I can put a list of things together. I've got a bunch of Heathkit equipment, and I know some of you guys know what Heathkit is. I've got, I don't know, I probably have at least a half a dozen Heathkit things around here, from the old days. I'm looking at one right now, and I'm going to start showing those things, and I believe they're all working, but, so anyway, we can put a pile of things together and get you guys, a lot of people watching these videos are not subscribers, so if you just start subscribing, we can do this giveaway sooner. But there's a power supply. Where is it? See that HP power supply, that dual supply? That needs to be repaired. And then I think I'm going to give that one away. It's a nice supply. It's an HP. I mean, man, it's probably a collector's item. I don't know. But it's a really nice supply. One side works, one side doesn't. So we'll troubleshoot that. We'll fix that in one of the videos. And then I'll put that on the list. Yeah, I'm going to sell some things. I got to get some money so I can buy some new things. And also so I can pay, for all the shipping to give things away too. Because that, Yeah, I was telling my wife how many things I got to give away, and she's like, "Oh, that's going to cost a lot of money." So she runs off and ships things for me. But yeah, I buy things she doesn't know about. But when I have things shipped, she knows what I spend on that stuff. Anyway, that Tectonic scope, I think that's got to go. I don't know if you can see it in this camera. That THS 730A up there. I've had that for a long time. It's an awesome scope, but it's time to get rid of things clean, right? Get rid of things, bring more things in. So, all right, guys, thanks for watching. Let me know. Sorry for rambling. That's what I do, I guess. But see you next time. Oh, and by the way, before we say goodbye, 2 thumbs up to all the Patreons and my 3 members of the channel. You can become a member down below. There's a super thank you button down below. Buy me a cup of coffee or maybe a beer for a rant. Tell me what you want me to rant about. I got a rant, guys. Oh man, today driving to work, listen to this stuff about inverters and how to ground them. Oh, I'm just thinking like, oh, so much danger out there. So I got to straighten some things out so people aren't getting electrocuted. Anyway. Yeah, so I got a rant maybe to do about proper grounding. I've done a few videos on grounding, but I think there needs to be one specifically on inverters and grounding. What do you guys think? All right, time to say goodbye. Thanks for watching. Free way to support the channel. Use the links down below. I've got a bunch of links for different pieces of equipment and stuff like that. And some of them have discount codes, so use those. You save some money. And the other ones don't cost you any extra money. But yeah, some of them you can save some money. So making this video long by just rambling. All right, thanks for watching. We'll see you next time.